Hello everyone. What is Dataiku? Dataiku is a collaborative data science and machine learning platform designed to help businesses transform raw data into actionable insights. It provides tools for data preparation, analysis, visualization, and machine learning, enabling teams to work together efficiently on data projects. It integrates with many data sources and supports coding in multiple languages, including Python, R, and SQL. Design in Dataiku. When we talk about design in Dataiku, we're referring to the process of creating and managing projects within the platform. Here, design means opening an instance of Dataiku where you can create projects, organize your work into projects that can contain data sets, recipes, transformations, models, and dashboards. Build workflows. Design data pipelines by creating visual workflows that define the sequence of data processing steps. Collaborate. Work with team members by sharing projects, commenting, and reviewing changes. Dataiku solutions. Dataiku solutions are pre-packaged projects and templates designed to solve specific business problems or use cases. These solutions provide a starting point with pre-built workflows, data sets, and models, allowing users to quickly get started and customize them according to their needs. Plugins. Plugins in Dataiku extend the platform's capabilities by adding new features, connectors, and functionalities. They can be installed from the Dataiku plugin store and can include custom recipes, web apps, scenarios, and more. Plugins help tailor Dataiku to specific needs and integrate with various tools and services. Connections. Connections in Dataiku are used to link the platform to various data sources. These connections allow Dataiku to access data stored in databases, cloud storage, APIs, and other data repositories. Setting up connections is crucial for importing, exporting, and managing data within your projects. Code environments. Code environments in Dataiku provide isolated environments for running custom code. These environments can be configured to use specific versions of programming languages and libraries, ensuring consistency and compatibility across projects. They support Python, R, and other languages used in data science. Audit Trail. The audit trail feature in Dataiku tracks changes and actions performed within the platform. It provides a record of who did what and when, helping maintain accountability and compliance. This feature is essential for understanding the history of a project and identifying any changes that might affect its outcomes. Usage and monitoring in Dataiku involve tracking the performance and usage of the platform. This includes monitoring resource usage, project activity, and user engagement. Effective monitoring helps ensure that the platform runs smoothly and that resources are used efficiently. Users, profiles, and groups in Dataiku manage access and permissions within the platform. Users, individual accounts for people who use Dataiku. Profiles, define roles and permissions for users, determining what actions they can perform. groups, collections of users with shared permissions, simplifying the management of access controls. Subscription and plan. Subscription and plan refer to the different pricing tiers and features available in Dataiku. Depending on the subscription plan, users can access varying levels of functionality, support, and resources. Plans range from free tiers for individual users to enterprise plans for large organizations. Then next. Settings in Dataiku include configurations and preferences that control the behavior of the platform. This encompasses global settings, such as security, backups, and integrations, and project-specific settings, like data privacy and processing options. Then open the instance. Dataiku DSS, Data Science Studio. Dataiku DSS is a collaborative data science platform that allows data analysts, data engineers, and data scientists to work together on data projects. It provides tools for data preparation, machine learning, and data visualization. Projects. In Dataiku, a project is a workspace where you can organize all your data-related work, such as data sets, recipes, transformations, models, and dashboards. Projects help you keep all related work together and enable collaboration with your team. Workspace. The workspace in Dataiku refers to the overall environment where users can create and manage projects. It includes all the tools and resources needed for data analysis, such as data sets, recipes, models, and dashboards. Project applications. Project applications are reusable templates or workflows that can be used across multiple projects. They help standardize processes and make it easier to replicate successful workflows. Project folders. Project folders help you organize your projects within Dataiku. You can group related projects together, making it easier to navigate and manage multiple projects. Dashboards. Dashboards in Dataiku are used to create visualizations and reports based on the data in your projects. They allow you to present your findings in an interactive and visually appealing way, making it easier to share insights with stakeholders. Wikis. Wikis in Dataiku are collaborative documentation spaces within a project. They can be used to document project goals, methodologies, data dictionaries, and any other relevant information. Wikis help ensure that everyone on the team is on the same page. Blank project. A blank project is a new project without any pre-configured settings, data sets, or recipes. It provides a clean slate for you to start working on your data project from scratch. DSS tutorial. The DSS tutorial is a guided set of lessons provided by Dataiku to help new users learn how to use the platform. It covers the basics of data preparation, analysis, and modeling, helping users get up to speed quickly. Sample projects. Sample projects are pre-built projects provided by Dataiku that demonstrate best practices and common workflows. They serve as examples to help you understand how to structure and organize your own projects. Import project. The Import Project feature allows you to bring in projects from outside Dataiku or from other Dataiku instances. This can be useful for sharing work between teams or environments. Each of these components plays a crucial role in helping users manage and execute their data projects effectively within Dataiku DSS. So I will start with creating the project. Click on blank project to create the new project, then after select the required source system, then you can create the workflow. Visual recipes in Dataiku. Visual recipes in Dataiku are predefined workflows that allow you to perform common data manipulation tasks without writing code. Here's a brief overview of each. Sync. Copy data from one dataset to another. When you want to replicate or backup data. Prepare. Clean and transform data. Data wrangling tasks like filtering, parsing, formatting, and more. Sample or filter. Create a subset of your data based on specific criteria. Reduce data size for testing or focus on a specific segment of the data. Group. Aggregate data by one or more keys. Summarize data, calculate metrics like sums or averages. Distinct. Remove duplicate rows. Ensure data uniqueness, remove redundancies. Window. Apply window functions like running totals, ranks, etc. Analyze trends, calculate cumulative metrics. Join with. Combine data from two datasets based on a common key. Enrich data with additional attributes. Fuzzy join. Join datasets based on approximate matching of keys. Match records that are similar but not exactly the same, example slight name variations. GeoJoin. Join datasets based on geographical proximity. Combine data based on spatial relationships, example nearest locations. Split. Split a dataset into multiple datasets based on a condition. Divide data into training and testing sets, or separate by category. Top N. Select the top N records based on a specific column. Identify top performing items, like best-selling products. Sort. Order the rows in a dataset by one or more columns. Rank data, prepare for further analysis. Pivot. Transform rows into columns. Reshape data for better analysis or visualization, like creating a summary table. Stack. Combine multiple datasets vertically. Append data from similar datasets, like monthly reports. Generate features. Create new columns based on existing data. Feature engineering for machine learning models. Generate statistics. Compute summary statistics for a dataset. Descriptive analysis to understand data distributions and key metrics. Each of these visual recipes is designed to simplify complex data transformation tasks, making it easier to prepare your data for analysis, reporting, or machine learning. Code recipes in Dataiku. Code recipes in Dataiku allow you to write custom scripts to perform data manipulations that might not be achievable using visual recipes. Here's a brief overview of each type. Python. Use Python scripts to manipulate data sets. Complex data transformations, machine learning, data analysis, custom functions. Cleaning text data, performing advanced statistical analysis, or building machine learning models using libraries like Pandas, scikit-learn, or TensorFlow. R. Use R scripts for statistical computing and graphics. Data analysis, visualization, and statistical modeling. Performing hypothesis tests, creating advanced visualizations with Plot2, or building models using Carrot or Random Forest. SQL. Execute SQL queries to manipulate data stored in relational databases. Data querying, filtering, joining, aggregation. Writing a complex query to join multiple tables, calculate aggregates, or filter data based on specific conditions. Spark SQL. Use Spark SQL for distributed data processing on large data sets. Big data transformations, querying large-scale data sets. Running SQL queries on data stored in a Spark cluster, performing distributed joins, aggregations, or filtering. PySpark. Use PySpark, Python API for Spark, for distributed data processing. Large-scale data manipulation, machine learning, data analysis. Processing large data sets with distributed computing, building machine learning models using Spark MLab, or performing ETL tasks on big data. These code recipes offer flexibility and power, enabling you to perform sophisticated data manipulations, leverage advanced analytics, and handle big data processing tasks efficiently. LLM recipes in Dataiku. LLM, Large Language Model, recipes in Dataiku allow you to leverage advanced language models to perform various natural language processing, NLP, tasks. Here are the common LLM recipes available. Prompt. Use a language model to generate text based on a given prompt. Text generation, content creation, automated responses. Generating product descriptions, writing summaries, creating chatbot responses. Classify text. Categorize text into predefined classes using a language model. Sentiment analysis, topic classification, spam detection. Classifying customer reviews as positive, negative, or neutral, identifying the topic of news articles. Summarize text. Generate a concise summary of a given text. Document summarization, content aggregation, information extraction. Summarizing long articles, creating executive summaries of reports, condensing meeting notes. Embed. Convert text into numerical vectors, embeddings, that capture semantic meaning. Text similarity, clustering, semantic search. Finding similar documents, clustering customer feedback, enhancing search capabilities with semantic understanding. These LLM recipes leverage powerful language models to perform sophisticated NLP tasks, enabling you to automate and enhance text processing workflows in Dataiku. Other recipes in Dataiku. In addition to visual, code, and LLM recipes, Dataiku offers other recipes that support a variety of data processing, machine learning, and deployment tasks. Here's a brief overview. Labeling. Manually label data for supervised learning tasks. Preparing labeled datasets for training machine learning models. Labeling images for object detection, tagging text data for sentiment analysis. Export to folder. Export datasets to a specified folder. Save processed data to local or remote storage for later use. Exporting a clean dataset to a shared network drive or cloud storage. Push to editable. Convert a dataset into an editable format within Dataiku. Allowing users to manually edit data within the Dataiku interface. Making corrections to data entries, updating missing values. Predict. Use trained machine learning models to make predictions on new data. Applying a model to generate predictions on unseen data. Predicting customer churn, forecasting sales, classifying emails as spam or not spam. Cluster. Perform clustering analysis to group similar data points. Identifying natural groupings in data, such as customer segments. Grouping customers based on purchasing behavior, segmenting products by features. Evaluate. Assess the performance of machine learning models. Measuring model accuracy, precision, recall, and other metrics. Evaluating the performance of a classification model using a confusion matrix, ROC curve analysis. These recipes provide a comprehensive set of tools for labeling, exporting, editing, predicting, clustering, and evaluating data, enabling end-to-end data workflows within Dataiku. Flow zones in Dataiku. Flow zones in Dataiku allow you to organize and manage different parts of your data workflows within a project. This helps in improving the clarity, manageability, and collaboration of complex data workflows. Flow zones. Segment and organize your data pipeline into distinct sections. Enhance readability, maintainability, and manageability of workflows. Dividing a project into zones such as data ingestion, data preparation, feature engineering, model training, and evaluation. Move. Relocate datasets, recipes, and other elements between different flow zones. Reorganize your workflow components to better reflect the logical structure of your project. Moving a dataset from a general data preparation zone to a more specific feature engineering zone as the workflow develops. Share. Share flow zones or elements within zones with other users or projects. Facilitate collaboration and reuse of workflow components, ensuring consistency across projects. Sharing a common data preparation zone with multiple projects to standardize data cleaning and transformation processes. By using flow zones, you can structure your workflows in a way that makes them more intuitive and easier to manage, promoting efficiency and collaboration within your data team. Then next, datasets and recipes. Datasets. Datasets are collections of data that you work with in Dataiku. They can come from various sources such as databases, files, or APIs. Importing raw data for analysis, cleaning, and transformation. A dataset containing sales records imported from a CSV file. Recipes. Recipes are instructions that define how to transform data from one or more datasets into a new dataset. Data cleaning, transformation, merging datasets, and creating features. A recipe that joins customer data with transaction data to create a combined dataset. Labeling tasks. Manually labeling data for supervised machine learning tasks. Creating labeled datasets for training models. Tagging emails as spam or not spam. Visual analysis. Provides tools for visually exploring and analyzing data. Identifying trends, patterns, and outliers in data through charts and graphs. Using histograms, scatter plots, and box plots to understand data distributions. Saved models. Store and manage trained machine learning models. Reusing, sharing, and deploying models for predictions. A trained model for predicting customer churn stored for future use. Prompt studios. Interface for creating and testing prompts for language models. Developing and refining prompts for tasks like text generation and classification. Creating a prompt to generate automated customer support responses. Model evaluation stores. Store and compare the performance metrics of different models. Assessing and tracking model performance over time. Storing evaluation metrics like accuracy, precision, and recall for multiple models. Model comparisons. Compare the performance of different models. Selecting the best model based on evaluation metrics. Comparing the accuracy and F1 score of several classification models to choose the best one. Experiment tracking. Track experiments and model training runs. Monitoring and documenting the parameters, results, and performance of different experiments. Logging different hyperparameter settings and their resulting model performance. Notebooks. Interactive environments for writing and executing code. Data analysis, visualization, and prototyping models. Using a Jupyter notebook to explore data and develop a machine learning model. Web apps. Build interactive web applications. Creating dashboards, custom visualizations, and user interfaces for data applications. A web app that allows users to input data and receive predictions from a trained model. R Markdown reports. Create dynamic reports that include code, text, and visualizations. Documenting analysis and sharing results. An R Markdown report summarizing data analysis and model performance with embedded code and plots. Libraries. Manage custom code libraries. Reusing and sharing code across projects. A library of custom Python functions for data cleaning. Code studios. Environments for developing and testing code. Writing, testing, and debugging code in a dedicated interface. A Python code studio for developing data transformation scripts. Jobs. Schedule and monitor data workflows and tasks. Automating data pipelines and ensuring timely execution. A scheduled job that runs a data cleaning recipe every night. Data quality. Assess and monitor the quality of data. Ensuring data accuracy, completeness, and consistency. Setting up data quality checks to monitor for missing values and outliers. Scenarios. Automate workflows and handle conditional logic. Creating complex automation workflows with branching and conditional execution. A scenario that runs different data processing steps based on the results of data quality checks. Automation monitoring. Monitor and manage automated workflows. Tracking the status and performance of automated jobs and scenarios. An interface showing the success or failure of scheduled jobs and scenarios. Wiki. Collaborative documentation space within a project. Documenting project goals, methodologies, and key findings. A project wiki page detailing the data sources, pre-processing steps, and model descriptions. Dashboards and insights. Dashboards. Create visualizations and reports based on project data. Presenting findings and sharing insights with stakeholders. A dashboard showing sales trends and key performance indicators. Insights. Highlight key findings and trends from data analysis. Sharing important observations and actionable insights. An insight card highlighting a significant increase in customer churn rate. API Designer. Create and manage APIs for deploying data science models and workflows. Exposing machine learning models and data processing workflows as RESTful APIs. Developing an API that serves predictions from a trained model to be used in an external application. Bundles. Package and export projects or parts of projects. Sharing and deploying projects across different environments, example development to production. Creating a bundle of a completed data pipeline project for deployment on a production server. Variables. Define and use variables to parameterize projects. Making projects more flexible and reusable by using variables to define settings like file paths, thresholds, and parameters. Setting up a variable for the database connection string so it can be easily changed when moving from a development to a production environment. Version control. Manage versions of projects and track changes. Enabling collaborative development, roll back to previous versions, and better change management. Using Git to track changes to recipes, datasets, and notebooks, and collaborating with team members. Application Designer. Build custom applications within Dataiku that can include interactive elements, forms, and dashboards. Creating user-friendly interfaces for non-technical users to interact with data and models. Designing an application that allows sales managers to upload data and get sales forecasts without needing to know how the underlying model works. Settings. Configure various aspects of the Dataiku environment and projects. Customizing project settings, environment variables, and user preferences. Setting the default storage location for data sets, configuring data connectors, or adjusting memory settings for computation. Security. Manage access control, user roles, and permissions. Ensuring that only authorized users have access to specific data and functionalities. Setting up role-based access control so that only data scientists can modify models, while business analysts can view results.